Hi, we are from Subgroup 8 and this is our report on Practical 1 Spectrophotometry.
Hi, my name is Jolene Yoiting and my matrix number is 99321.
Hi, my name is Alexa Sherina Jacob and my matrix number is 98785.
Hi, my name is Letitia Enlin with matrix number 98782.
My name is Ira Wahyuni binti Abdul Hadi with matrix number 99162.
The objectives of this experiment are to understand spectrophotometry fundamental and how it's used in biological analysis, to determine the adsorbance spectrum of an unknown compound for qualitative analysis, to determine the concentration of unknown protein samples, and to construct a standard calibration curve using known concentrations of BSA protein. The materials are spectrophotometer, cuvette, Bradford reagent, distilled water, test tubes, test tube rack, micropipetters, 70% ethanol solution, 1 mg per ml BSA protein, and standard unknown protein solutions of A, B, and C. Spectrophotometer is to measure the adsorbance of a solution. Cuvette is a small transparent container to hold sample for analysis in spectrophotometer. Micropipette is a precision instrument used to measure and transfer a small amount of liquid accurately, and Bradford reagent bind to protein to allow protein concentration measurement using spectrophotometer. Moving on to the procedure, part 1. First, 4 ml of distilled water was placed in each of 7 test tubes using 1000 microliter micropipetter. Since the micropipetter being used is 100 to 1000 microliter, so we need to do it for 4 times to get 4 ml. Then, 1 ml of Bradford reagent was added into the test tube. This is repeated for another 6 test tubes filled with 4 ml of distilled water. Then, 50 microliter, 100 microliter, and 200 microliter of BSA protein standard were added into the test tubes in duplicate. One test tube will be left as blank. This time, 10 to 100 microliter and 100 to 1000 microliter micropipetters are being used. After that, all of the test tubes will be placed in the mixer to mix them properly. All of the mixtures were then placed into a cuvette, including the one that was set as blank. Finally, all the mixtures in the cuvette are brought to the spectrophotometer in order to measure their adsorbance. First, the spectrophotometer had to be blanked by the cuvette that does not contain BSA protein standard. Then, the samples were read from least concentrated and the adsorbance of each samples are recorded. First, 4 ml of distilled water was placed in each of 7 test tubes using 1000 microliter micropipetter. Since the micropipetter being used is 100 to 1000 microliter, so we need to do it for 4 times to get 4 ml. Then, 1 ml of Bradford reagent was added into the test tube. This is repeated for another 6 test tubes filled with 4 ml of distilled water. Then, 100 microliter of unknown protein A, B, and C were added into the test tubes in duplicate. One test tube will be left as blank. After that, all of the test tubes will be placed in the mixer to mix them properly, including the one that was set as blank. All of the mixtures were then placed into a cuvette, including the one that was set as blank. Finally, all of the mixtures in cuvette are brought to the spectrophotometer and the adsorbance was set at 595 nanometer. First, the spectrophotometer had to be blanked by the cuvette that does not contain any unknown protein concentration of A, B, and C. Then, the concentration of unknown protein A, B, and C were recorded. The above is the result for part 1 of the experiment. The average adsorbance and the standard duration of adsorbance at 595 nanometer were calculated for each 50, 100, and 200 microgram per ml protein concentration. Then, a standard calibration curve of average adsorbance at 595 nanometer versus protein concentration were constructed using known concentrations of BSA protein. This shows a strong linear relationship, which consistent with the Beer-Lambert law principle. The above is the standard curve for protein assay. The standard curve equation y equals to 0.02x also confirmed that the adsorbance increased proportionally with the protein concentration. This validates the reliability of protein assay quantification. Then, the analysis of unknown sample A, B, and C using standard curve determine their protein concentration. These values were obtained by substituting measured average adsorbance value into the derived linear equation, which shows good precision with relatively low standard deviation. Small deviation indicates minimal variability between replicate measurements. However, the data above reveals that the standard deviation of sample A was higher compared to B and C, which might be caused by pipetting errors or inconsistent mixing with Bradford reagent during sample preparation. In conclusion, this experiment effectively illustrated how to measure protein concentrations in solution using spectrophotometry and the Bradford protein assay. In part 1, the standard curve plotted confirmed the Beer-Lambert law. This indicates high accuracy in pipetting and measurement, especially 100 and 200 microgram per ml as shown by low standard deviation. In part 2, the protein concentrations of unknown sample A, B, and C were calculated using the standard protein curve. All of the estimated concentrations were within the assay's effective adsorbance range, which demonstrate the reliability and sensitivity of method. Overall, this experiment fulfilled its objective by showcasing both qualitative and quantitative analytical techniques, which reinforce the importance of spectrophotometer as a precise tool for photochemical measurements. The above is our group reflections. In the aspect of new learnings, in this experiment, we gain deeper understanding of the usage of spectrophotometry in biological analysis, such as quantifying protein concentrations using Bradford assay. We also learned how to construct and interpret a standard calibration curve, perform both qualitative and quantitative analytical techniques, and apply Beer-Lambert law. All of us also learned the skills in accurate pipetting using micropipetters, handling cuvette, and using spectrophotometer. One of the challenges faced during the experiment is ensuring precision during pipetting. This is because slight errors can affect adsorbance reading and the standard curve. To avoid contamination between samples also required extra care in order to ensure the precision of the experiment. So, the suggestions for improvement is that more practice on pipetting techniques are suggested to improve the experiment as we are not familiar with micropipetters. Besides, proper use of the spectrophotometer also had to be practiced. Thank you.